Welcome back for another edition of verifying your trig identities. Remember, the identities that we're going to be using to prove these, we'll be using reciprocal identities, Pythagorean identities, some negative trig identities, and we'll do what we can to simplify the expression, the more complex side of the expression, so that we end up with the equivalence that is listed on the right hand side. Don't forget, we'll use the identities and definitions as well. We'll substitute in what we can until everything kind of claps in place. One real important thing to note here, as we're working with verifying trig identities, it's important to remember that there's more than one way to solve these problems. Some of you might be looking at this problem that I have listed here, and you might think, I might be able to factor secant squared minus 1. Because that's just like x squared minus 1. I could factor that into x plus 1 times x minus 1. Well, that might be a suitable way to proceed with this. Some of you might be able to look at this and see that as I work through this, I think that secant squared theta minus 1, that reminds me of a possible Pythagorean identity. So you'll want to carefully consider your options here. Pick one way and run with it. Do everything you can to it until you get to a point where, alright, this is just getting more complex than it needs to be. If you reach a point like that, start over. Erase what you've got and find a different track, because there is more than one way to do these. And that's one of the things I really love about these puzzles. Verifying trig identities, there's almost always more than one way to verify the validity of the statement listed. So with that said, let's jump to the next slide, proceeding with this particular problem here. And I'm going to choose to proceed in a fashion of substituting in a trig identity. Okay, so I know that the secant squared minus 1, that is going to be equal to, let's change our pen thickness here real quick. I'll erase that little bit we have there. Alright, so this is going to be equal to tangent squared of theta over secant squared theta. Okay, now remember, the goal here is to prove that this is equal to sine squared of theta. Okay, so let's go ahead and I'll go ahead and add that part to this. Remember, the goal here is to hit sine squared of theta. Okay, so as I consider that, what else can I do to what I have on screen right now? Tangent squared over secant squared. And the goal, keep in mind, is to convert everything so that it's equal to sine squared. So one possibility here would be to convert the statement that we have right now, and let's change it over to sines and cosines. So tangent squared is sine squared over cosine squared. And then, what about the definition of secant squared? Well, secant squared is the same thing as 1 over cosine squared. So if I take sine squared over cosine squared and then I divide by 1 over cosine squared, that's the same as multiplying by cosine squared. Remember, that's division of fractions is the same as multiplying by the reciprocal of the fraction in the denominator. Okay, so I have this. And then I can follow through with a little bit of algebraic simplification here. My cosines are going to cancel out. And the only thing I'm left with then is sine squared of theta. So there you have it. Didn't even have to wave a magic wand. We were able to logically proceed from top to bottom. And we were able to prove that the secant squared theta minus 1 over secant squared theta is equal to sine squared theta. And that is exactly what we were trying to prove. In the meantime, keep looking for more examples of these in nature. And within the next couple of slides, presentations, we'll actually introduce some of the other trig identities that are out there. And we'll save that for down the road a little bit. In the meantime, thank you very much. Have yourself a great day, and we'll talk with you soon.